Chapter 8, Video 5. Today we're going to talk about atrial flutter in this video. With atrial flutter, we have an irritable atrial focus. So remember, we're talking about an atrial rhythm here. So there's a spot in the atrium that's irritated. However, it's not coming from the sinus node. So the rhythm results when one irritable atrial focus fires out regular impulses at a rate so rapid that a fluttery pattern is produced instead of a P wave, okay? So remember, our sinus node is the pacemaker of the heart, but this rhythm is happening in the atrium. We have a foci that's irritated, and it's firing out really, really rapid. It's usurping the sinus rhythm, and we see a P wave that's distorted, and it looks kind of like it looks like a flutter, okay? It looks like a sawtooth. What happens is the AV node, remember the AV node is our lower pacemaker. So if something were to happen to the sinus node, then the AV node could actually come in and produce a rhythm. The AV node is also known as the gatekeeper, okay? So when the SA node fires and it sends impulses down, if something happens in the atrium like atrial flutter, the AV node has the option to block it so it won't send these signals through the remainder of the pathway. So the AV node will actually selectively block some of these impulses. They only let some of them through. So that way the ventricles don't become irritated. So we have the top of the heart, which is the atriums, the two atrial chambers, and then we have the bottom of the heart, which is the ventricular chambers. We have the SA node, the AV node, and the ventricles that serve as the pacemaker. So what happens is that AV node says, whoa, Nellie, I have got way too much stimuli coming in. This atrium is super irritated, and if I let this pass through to the ventricles, then the ventricles could become irritated. So the AV node steps in and says, no, I'm only letting X amount through because I can't overload the rest of the cardiac electrical conduction system in the pathway. And so with atrial flutter, you're going to see that flutter pattern rather than the P wave. The atrium is firing so fast that the AV node has to block these impulses to keep everything from going through and overloading the ventricles. An example of this would be a tennis ball machine firing. The impulses are so fast you can't hit them, so you basically duck to miss them. That's the example that the book gave. But I'll just like to say that they're the gatekeeper. The AV is the gatekeeper. It only lets certain amounts of signals come through, because if too many go through, then the rest of the heart's going to become irritated. Scrolling on down, we're going to look at the criteria for atrial flutter. You need to know this criteria. You need to make note cards to remember the criteria for each of the different rhythms, okay? You've got to know this. So with atrial flutter, we have an atrial rate here of 250 to 350. The ventricular rate is going to vary, and it's going to vary depending on conduction. It's going to vary depending on how many signals the AV node allows to let through, if that makes sense. If you don't understand that, if you don't understand what I'm saying with that, please let me know. But remember, we said the AV node is the gatekeeper. The atrium's firing at a really, really rapid rate, but the AV node is only going to let certain amounts of these signals come through. So however many it comes through is what the ventricular rate will be. So it's going to vary depending on what that AV node allows. The regularity can be regular, or it can be either irregular. We do not see P waves. They are flutter waves instead, which I will show you in the future slide. The PR interval is not applicable here because we do not have P waves. If we don't have P waves, we cannot count a PR interval. The QRS, again, is still normal. It's less than 0.12 seconds. Remember, when we have a normal QRS, the QRS represents ventricles, okay? So if this is normal, when we're diagnosing the strip, we know that we're not dealing with a ventricular rhythm, that it's got to be happening somewhere else. P waves are what happens in the atrium, so we know that the problem lies within our P wave here. So this is, we can figure this out using this. With atrial flutter, we do not have P waves. There are no P waves. We have flutter waves. Flutter waves are present instead. Atrial flutter almost always can be seen in patients with heart disease. When we talk about the regularity of it, let's go back to the regularity here. I'm going to talk about that for a minute. We have a regular rhythm if the conduction ratio is constant, and if it's an irregular rhythm if the conduction ratio varies. And what we mean by that, when the AV node is working and it's allowing those signals to go through, if it's a constant pattern, if it remains constant and it's constant across the board as to how many impulses it lets through, we will see a regular rhythm. But if it's not constant, if it's just sporadically allowing signals to get through, then that's when we're going to see that irregular rhythm. Again, no P waves, they're only flutter waves. There will be 2 or more flutter waves with each QRS, okay? So you're not going to see just one flutter wave. You're going to see 2 or more flutter waves in front of each QRS. The easiest way to find all flutter waves is to find 2 waves back to back and note the distance between them. You can go from top to top or bottom to bottom. Some flutter waves may be hidden in the QRS complex. And now we're going to talk about the different causes. Causes of atrial flutter, atrial flutter almost always implies heart disease, okay? A pulmonary emboli or valvular heart disease or lung disease, thyroxetoxicosis, this can cause atrial flutter. It's tolerated well at a normal ventricular rate, but it can become a problem if the ventricular rate gets out of hand and we see that decreased cardiac output. So it really depends on what's happening and what our rate is. Decreased cardiac output, we're going to see it at higher rates because the heart's not going to be putting out. The treatment here is going to be digitalis, calcium channel blockers, beta blockers, carotid sinus massage, and electrical cardioversion. Carotid sinus massage is rubbing that carotid artery in the neck to stimulate that vagus nerve. So that's what we're talking about with that. So now I'm going to move down and we're going to go through a strip here. Don't become overwhelmed when we look at this strip. Remember, we've got to work through those 5 questions. So I've seen in the past that when people look at a strip and it's not the typical strip, that they automatically panic and they're saying, oh my God, I don't know what this is. I'm trying to figure it out. Well, you can't figure it out unless you go through the 5 questions of how to interpret that strip. So the very first question that we're going to ask ourselves, do we have QRS complexes? And the answer here is yes, we do have QRS complexes. And if we count the width between them, they're normal and they're shaped the same. And then we're going to take and count the little blocks between the R and the R. Between this R and this R, and write the number down up top. Between this R and this R, and write it down. Or either we can take a piece of paper, a scratch piece of paper, and put a mark on it and trace it out. But we're going to see that this is a regular rhythm, okay? So we're looking for regularity. It is a regular rhythm. But the atrial rate, I got QRS. You can tell you got the T here. And then we got P, QRS. Our T, again, looks the same. So our T's look the same across the board. But then what do we have here? We have oddball-looking P waves. We got multiple P waves. And they're pointed backwards. These points all flow the same. So that kind of tells you that that's that flutter wave. That's that sawtooth pattern that you see. So we don't have a regular P wave. We only have flutter waves, okay? But they're regular. The QRS complex, again, is 0.08. So that tells us that we have atrial flutter. because we know we have a problem with the P wave. We can clearly see it, and this one's easily defined because we have that sawtooth pattern. We see those flutter waves. So we're looking for that sawtooth. And you may hear it referred to as sawtooth. You may hear those waves referred to as sawtooth waves. So when you hear sawtooth, you need to automatically think atrial flutter. If you have any questions, please let me know.